Hello everyone, myself Gayatri Devi, Senior Lecturer in Mathematics, working at JN Government Polytechnic, Ramantapur, Hyderabad. In this session, I am going to explain a topic from the subject Applied Engineering Mathematics, which is under the curriculum C18F with the subject code Common 301F. The topic is integration, which is a major topic, so we can't complete in one session, but we know the basics of this integration in this session. On completion of this topic, you should be able to understand what is integration, how it is defined, what is the importance of integrating constant, why integral f of x dx is called indefinite integral of f of x with respect to x, the geometrical interpretation of indefinite integral, the properties of indefinite integrals, and finally, the standard formulae for integrals based on differentiation. So, we are going to understand all these points in this session. Now, introduction. Finding a function when its rate of change is known as integral calculus. Finding a function when its rate of change is known is called integral calculus or integration. Definition is given as integration is defined as the inverse process of differentiation. Inverse process of differentiation. You have already come across through this differentiation in your second semester. So now you have to learn how to inverse it. And it is sometimes termed as antiderivatives. The integration itself is termed as antiderivatives. And it is denoted by the symbol integral, which is the extended S. Extended S in the form of like this. Now, y equal to integral f of x dx is called the integral of f of x with respect to x. Integral of f of x with respect to x. And this f of x is called integrand. The function for which you are finding integration is called integrand. The very important point is dy by dx. That is d by dx of some function capital F of x is equal to small f of x. And again d by dx of some capital F of x plus c, that is also f of x, because the d by dx of constant equal to 0. So the derivative of a function with a constant and without constant, both are giving same function. If you want to find integration, because of it is inverse process of differentiation, by integrating this small f of x, you should get capital F of x plus c. So integral f of x dx equal to capital F of x plus c, where c is called as a constant of integration. And the capital F of x plus c is called the indefinite integral of f of x with respect to x. So integration of f of x will give this capital Fx, but there may be a constant, may not be a constant because of the derivative is 0. So for that we use every integration a constant c, which is called integration constant. The derivative of a function, when it exists, is a unique function, but the integral of a function is not so because of this constant. It varies. So, coming to the geometrical interpretation of indefinite integral. The indefinite integral of a function represents geometrically a family of curves. Observe this. Let f of x equal to x. Then integral f of x dx equal to integral x dx. We'll go through the formulas in the next slide. It is integration of x power n is x power n plus 1 by n plus 1. So using that form, we are getting x square by 2, and automatically integration will give a integrating constant c. Let this equal to y. Then for different values of c, we will get different family of integrals as follows. If c equal to 0, then y equal to x square by 2. If c equal to 1, y equal to x square by 2 plus 1. And if c equal to minus 1, y equal to x square by 2 minus 1. Like that, we can take some points and plot a diagram, which is giving you a family of curves. So each member of the family can be obtained by shifting any one of the curves parallel to itself. So this is the geometrical application of interpretation of indefinite integral. So geometrical interpretation of indefinite integral, which gives you indefinite integral of a function represents geometrically a family of curves because of its integrating constant. Okay, now we go to the properties of indefinite integral. Integral f of x plus r minus g of x dx equal to integral f of x dx plus integral g of x dx. And integral k into f of x dx equal to k into integral f of x dx, where k is a real number. Plus or minus multiplication with constant are only explained here. So integration of f of x into g of x, integration of f of x by g of x are not defined here. So we'll go through the points in the coming sessions. Now, because of antiderivatives, we can list out the formulas. The following list of formulae for integrals is based directly on the result of differentials, which have been studied earlier. It is necessary to commit them to memory. We know the derivative forms, and just taking reverse, we can frame the integration forms. Derivative of x power n plus 1 by n plus 1 equal to x power n, whereas integral x power n dx equal to x power n plus 1 by n plus 1 plus c. This is the only point to remember. But one more condition here is n not equal to minus 1. N not equal to minus 1, because if it is minus 1, we are getting, here is infinity form. So you have to define x power minus 1 integration separately, that you observe here. X power minus 1 means 1 by x, so it is integral 1 by x dx which should give a function whose derivative is 1 by x. That is the concept. So, whose answer is 1 by x, the differentiation, that will come as the answer of integration. So here integral 1 by x dx equal to log x because of derivative of log x equal to 1 by x. So now d by dx of x equal to 1. So integral of 1 equal to x. Every integration is giving you plus c. Similarly, exponential function and a power x function and trigonometric functions all are expressed here. In derivative of sin x is cos x. So integral cos x equal to sin x. Derivative of cos x is minus sin x. So integral sin x equal to minus cos x. Plus c is must. Derivative of tan x equal to secant square x. So integral secant square x equal to tan x. Derivative of cot x equal to minus cosecant square x. So cosecant square integration equal to minus cot x. In the similar way, we can go for inverse forms also. Derivative of sin inverse x equal to 1 by root of 1 minus x square. Integral 1 by root of 1 minus x square dx equal to sin inverse x plus c, which is again equal to minus cos inverse x plus c, because the derivative of cos inverse x is having same form just with the difference of minus. So whose integration may give either plus sin inverse x or minus cos inverse x. So that you can express in both these ways. Similar way, derivative of tan inverse x equal to 1 by 1 plus x square. So integral 1 by 1 plus x square dx equal to tan inverse x plus c, and one more way, minus cot inverse x plus c. Next, secant inverse. Here also secant and again cosecant inverse, because both are only differ by minus. So in this way, hyperbolic function forms are also given. These are all framed from derivative forms as a reverse process. Integration is reverse process. Depending on that word, we are framing the fundamental forms of integration. Right. Now we go to problems. In the beginning of doing these problems, must be alert. Integrate the following: 3x square plus 2x plus 5. Integrating this with respect to x means you have to write the symbol integral of, take the function within brackets, write dx because with respect to x, as integration of sum of functions is equal to each one integration. So take the term, each term separately, and then integrate. So here x square integration is x power n plus 1 by n plus 1. X integration is x power 1 plus 1 by 1 plus 1. And constant integration is constant into x. Integration constant c, you have to add it. So that integration is done term by term. Using the same formula, integral x power n dx equal to x power n plus 1 by n plus 1. Come to next one. X to the power of 3 by 2 minus 1 by x square plus 5 by x minus 7 is the function given to you. Now integral of this given function with respect to x equal to, as like above, you can split each term separately and take the integration. So x to the power of 3 by 2 is x to the power of n form. So n plus 1 by n plus 1 is giving you 3 by 2 plus 1 by 3 by 2 plus 1. And here 1 by x square means you have only formula for 1 by x, that is only where the power n equal to minus 1. Other than minus 1, that is minus 2 to minus infinity, plus 1 to plus infinity, everything comes under the form x power n integration. only when n equal to -1. That means only for 1 by x, the integration is different. So here it is 1 by x square. So you have to take it as x power -2 integration. So integral of x power -2 dx plus 5 into integral 1 by x dx. You have another formula log x. Integration of constant is giving you constant into variable x. Now simplifying this, you are getting x power 5 by 2 by 5 by 2. And x power -2 is giving -2 plus 1 by -2 plus 1. Remaining terms as it is. Now this is equal to 2 by 5 x power 5 by 2 plus 1 by x. This minus and minus is giving plus, and x power -1 is coming down to the denominator. Plus 5 log x minus 7x plus c. So observe carefully what is the power and for which the formula is different. So only for 1 by x the formula is different. For all other powers of x, that is except -1, all are coming under x power n formula. Apply x power n plus 1 by n plus 1. That is the point to remember here. Coming to next one. We have different types of functions. So already we come across to the forms of different types of functions. How to find the integral values. So using those forms we are going to do here. Integral 2 e power x plus 3 sin x plus 4 secant square x into dx. As usual, you can split each term with the integral dx. Take the integration separately. Now 2 into e power integral is giving you e power x. 3 into integral sin x is giving you sin integration is minus cos x. 4 into integral secant square x is giving you integral secant is tan x. So first, you have to remember the formulas. So go through the formulas thoroughly and memorize them. Then you can answer very easily. Now, after completion of integration, you have to add the constant of integration c. Coming to next bit, integral e power x plus 2 sin x plus 6 by root of 1 minus x square. One exponential, one trigonometric, one algebraic. Looking like algebraic. If we go for integration, separate the term and apply integral dx, so that you are getting integral e power x dx is giving e power x, integral sin x is giving 2 into minus cos x, integral of 1 by root of 1 minus x square, which is the form of inverse functions, that is sin inverse or minus cos inverse. You can take any one of them. I'm taking sin inverse x here, so e power x plus 2 into minus cos x plus 6 sin inverse x plus c. Coming here, hyperbolic functions, a power x plus 3 secant square x minus 2 cos hx. For this whole, you have to find integration with respect to x. As usual, split the integration to each term. So integral a power x dx plus 3 into integral secant square x dx minus 2 into integral cos hx dx. A power x integration form is a power x by log a. And integral cos hx is sin hx. So now a power x by log a plus 3 into integral secant square is tan x, and this cos hx integration is sin hx. So if you know the exact formulas, then only you can answer. Here is no procedure. You have to remember each and every function's integration formula. So inverse function a power x cos hx, e power x sin secant square, every function formula you should remember and answer the integration of given problem. Now, one more. X power 5 plus 5 power x plus 5x. Integration is required with respect to x. X power 5 is in the form of x power n. It is n. This 5 is constant. So it is in the form of x power n. Observe these two. this is x power n, this is a power x, where a equal to 5. So this form, this is 5 power x is in the a power x form. X power 5, very simple, algebraic. So coming here, x power 5 plus 1 by 5 plus 1 answer. I am not splitting again integral, as we have already habituated. You can understand directly the answer. The x power 5 is x power 5 plus 1 by 5 plus 1. 5 power x is, applying this form, 5 power x by log 5 plus 5 into x, where x power is 1. So 1 plus 1 by 1 plus 1, which is giving you x power 6 by 6 plus 5 power x by log 5 plus 5 into x square by 2. Finally, integrating constant c. So, all the functions, secant square, sine, e power x, a power x, cos hx, sine hx. So you have to remember all the integration formulas very well. Then you can answer the problems very easily. Next. Till this, we come across through only plus minus functions. F of x plus r minus gx, like that. Now we are going for product. Integral 1 minus 2x into 2 plus 3x into dx. There is no special form mentioned till now for product of integration. So it is, these two are very simple algebraic terms. You can just directly multiply them to get an expression, which is giving you 2 minus x minus 6x square. So integration of an expression with respect to x, which you already know how to do. So each term is taken and integration is applied. Integral 2 is giving 2x. Integral x is giving you x square by 2. X power 1 plus 1 by 1 plus 1. Now we have developed to write, instead of 1 plus 1 by 1 plus 1, directly x square by 2. So one step, minus 6 into, given is x square, so integration is giving you x power 2 plus 1 by 2 plus 1, which is x cubed by 3. Finally, integrating constant c. After simplification, we are getting 2x minus x square by 2 minus 2x cubed plus c. So here we reduced one step. Instead of writing x power 1 plus 1 by 1 plus 1, that is applying the formula n plus 1 by n plus 1, we are directly writing what is the value finally we are going to get. Because of power 1, 1 plus 1 is 2, similarly 2. Because here is x square, you have to integrate with respect to x. The x square is giving you 2 plus 1, that is 3, by 2 plus 1, 3. So this is development. Now we are following. Coming to next one. Integral x square plus 2x plus 2 by x power 4 into dx. No special formula is given for fraction. We come across it through only integral f of x plus r minus g of x dx equal to integral f of x dx plus r minus integral g of x dx. And one more, integral of k into f of x dx equal to k into integral f of x dx. That's all. So no form for integral f of x by g of x, integral f of x into g of x, like this. You have to apply your algebraic knowledge to simplify the product and fraction. Because of x power 4 in the denominator, split each term with the denominator by x power 4. X square by x power 4, 2x by x power 4, 2 by x power 4, which gives you 1 by x square, 2 by x cube, 2 by x power 4. Now, to integrate this, you have to represent in the form of x power n. So bring the denominators to numerator, taking the power minus. Integral x power minus 2 plus 2x power minus 3 plus 2 into x power minus 4. Where you are already having minus power, So by integration, n plus 1 by n plus 1 is giving you, instead of minus 2, minus 1. So minus 2 plus 1 means reducing 1 minus. Similarly, minus 3, reduce it to minus 2. Minus 4, reduce it to minus 3. So n plus 1 by n plus 1, n plus 1 by n plus 1. Like that you are getting x power minus 1 by minus 1, plus 2 into x power minus 2 by minus 2, plus 2 into x power minus 3 by minus 3. Finally, integrating constant c. Rearranging them, the minus powers are taken to denominator, so you are getting c minus 1 by x, minus 1 by x square, minus 2 by 3 x cube. Next model. This is product, this is fraction. Here it is included both product and fraction. Because of algebra, you can simplify very easily. X square minus 5x plus 6. You are going to get on multiplication of these two. By root x as it is. Because of single term in denominator, you can split like this. Now, x square by root x is giving you x power 3 by 2 power. 5x by root x is giving 5 root x. And 6 by root x is giving you 6 into x power minus 1 by 2. Now, applying x power n integral form, you are getting n plus 1, 3 by 2 plus 1, 5 by 2 by n plus 1, 5 by 2 minus x power half. Half plus 1 is 3 by 2. Denominator is also 3 by 2. X power minus half. So x power minus half when added with plus 1, you are going to get plus half. So x power half by half. Finally, answer is 2 by 5 x power 5 by 2 minus 5 and this 2. So 10 by 3. This 2 will come to the numerator. So 10 by 3 x power 3 by 2 plus 12 root x plus c. So dividing with the denominator and making the powers into numerator only, there is only term. Because of denominator single term, you are able to do like this. If it is not single one, you have to go for another style of simplification. Coming here, integral x square plus 1 by x square whole square dx, which is a simple whole square. Expand and simplify. Finally, you are getting x power 4 plus 2 plus 1 by x power 4. Integration is required with respect to x. X power 4 means 4 plus 1, 5 by 5. Constant 2 is with respect to x giving x. X power 1 by 4, 1 by x power 4 is giving you x power minus 4. So minus 4 plus 1 minus 3 by minus 3. Finally, x power 5 by 5 plus 2x minus 1 by 3 x cube plus c. So all these problems are simplified using only algebraic knowledge. Whole square expansion, multiplication, simplification, and dividing with the denominator. Coming to next. So algebraic models are over. Now we are going to trigonometric type of integrations. For that, you have to recollect the following trigonometric formulae that you have already come across through in your first semester. So the fundamental rules: sin square plus cos square equal to 1, 1 plus tan square theta equal to secant square theta, 1 plus cot square theta equal to cosecant square theta. These three are called fundamental rules. Coming to minus theta forms, sin of minus theta equal to minus sin theta, cos of minus theta equal to cos theta, and tan of minus theta equal to minus tan theta. The very special formula of cos. Cos of minus theta equal to cos theta is giving you more comfortable formulas. With this property, it is giving more comfortable formulas in the multiple angles and as well as submultiple angle forms. Coming to multiple angle forms, sin 2 theta equal to sin theta into cos theta, and cos 2 theta is expressed in three ways: cos square theta minus sin square theta, which is equal to 1 minus 2 sin square theta only in terms of sin, and which is equal to 2 cos square theta minus 1, that is only in terms of cos. Coming to tan 2 theta, equal to tan theta by 1 minus tan square theta. You have multiple forms only for 2 theta and 3 theta in your syllabus. So coming here, just for change, we use sin 3a equal 3 sin a instead of theta. Any angle you can, theta, capital A, anything you can use. So sin 3a equal to 3 sin a minus 4 sin cube a. Cos 3a equal to 4 cos cube a minus 3 cos a. Tan 3a equal to 3 tan a minus tan cube a by 1 minus 3 tan square a. Submultiple forms. These are from multiple forms only. When you are having here 2 theta, you are going to get theta and theta. If this itself is theta, you are going to get theta by 2, theta by 2. So the forms are modified. Sin theta equal to 2 sin theta by 2 into cos theta by 2. Cos theta equal to cos square theta by 2 minus sin square theta by 2, which is equal to 1 minus 2 sin square theta by 2, which is equal to 2 cos square theta by 2 minus 1. Similarly, tan theta is expressed as 2 tan theta by 2 by 1 minus tan square theta by 2. From these, you can form what is sin theta by 2. Similarly, what is cos theta by 2. Like that also you can express. So, but we require only this knowledge to go through the integration of trigonometric functions. Now, integral 5 tan x minus 2 cot x whole square dx. First you have to expand whole square. That is giving you 25 tan square x minus 10 tan x into 2 cot x plus 4 cot square x dx. Integration of tan square is giving you, there is no formula for integral tan square. Only integral secant square is there. So transfer this tan square x using fundamental rule as secant square x minus 1. Similarly, no formula for integral cot square x. You have integral cosecant square x formula. So connect these two through the fundamental rule that cot square x is replaced with cosecant square x minus 1 to get the integration. So these two are connected to the secant square x and cosecant square x using fundamental rule. Now you can apply the integration. 25 into integral secant square x is tan x. 25 into integral constant is x. Minus 20 integration is 20x. And 4 cosecant square x integration is 4 into minus cot x. Minus 1 constant integration is giving you x. It is multiplied with 4, so minus 4x. Finally, we are getting 25 tan x minus 4 cot x. Total together minus 49x. 25, 20 and 4. Minus 49x plus c. So here we cannot find integral tan square directly. We are changing it as secant square x minus 1. Similarly, 4 cot square x is here. So cot square is changed as cosecant square minus 1 to get the formula. Now, so using fundamental rule, you are able to find the integration of this problem. Next, integral of root of 1 minus cos 2x dx. This 1 minus cos 2x can be written as 2 sin square x using the form cos 2x equal to 1 minus 2 sin square x multiple formula. this cos 2x to the right side and 2 sin square x to the left side, which is giving you integral root of 2 sin square x. Out of root 2 is root 2 only, but sin square out of root is giving you sin x, which is a direct simple formula of integral sin x, which is equal to minus cos x. So we can simplify this using multiple form. The answer is c minus root cos x. Next, root of 1 plus sine 2 theta integration with respect to theta is required. 1 plus sine 2 theta, it is because of cos multiple angular, you can simplify using this form. Because of cos multiple form is having 3 options, but whereas sine is having only one option, that is 2 sine theta into cos theta. So thinking of this only one option, we are trying to use this 1 as sin square plus cos square. This is also a fundamental rule. So 1 is taken as sin square theta plus cos square theta, and sin 2 theta formula is 1 and only 2 sin theta into cos theta, which is a square plus b square plus 2ab form. So a plus b whole square. Because of root, the whole square will cancel and we'll get integral of sin theta plus cos theta into d theta. That is equal to minus cos theta plus sin theta plus c. Coming to one more of fraction form. There in algebra, we divided if the denominator is having single term. Similar, we follow here. So integral 1 minus sin x by cos square x dx. Integral 1 by cos square x minus sin by cos square x into dx. 1 by cos square is secant square x. Sin by cos square equal to sin by cos tan into 1 by cos secant. So it is changed as integral secant square x dx minus integral secant x tan x dx, which gives a comfortable form. Integral secant square x equal to tan x, a direct formula, and similarly integral secant x to tan x is a secant x, very direct form, plus integrating constant. So single term in the denominator is giving you comfort to split the numerator and to get the secant square x and secant x tan x. Here it is reverse. Integral cos square x by 1 minus sin x, where the denominator is having 2 terms. So there is no choice of this type of simplification. Right, we are trying in another way. Because of trigonometric functions, you can use your knowledge to simplify this in many ways. So cos square is written as, according to fundamental rule again, we are taking help of the fundamental rule and writing 1 minus sin square x. Again, we are using our algebraic knowledge, a square minus b square as a plus b into a minus b. So cancellation of this term, this happens. Now finally you have to find integration of 1 plus sin x into dx, which is very easy. Integral of constant is x, integral of sine is minus cos. So observe these two problems. What is the difference you have to follow? When the denominator is single term, split to the each term of numerator, then try to find integration. If the denominator is having more than one term, try to use the help of trigonometric forms and as well as algebraic forms and some other models to simplify it and get integrated. Okay, so you have to recollect your trigonometric forms also. That's why I have given the recollect of forms which are required to do the problems. Coming to next, integral sin cube x plus cos cube x by sin square x into cos square x. Denominator is single term only but product. Because of single term, split it. Sine cube by sine square x into cos square x, cos cube x by sine square x into cos square x. So according to sine cube sine square, we are getting sine x in numerator and denominator is cos x into cos x. You can write cos square, but for comfort I am writing cos x into cos x, so that 1 by cos is secant, sine by cos is tan. So the first term is giving you secant x into tan x. Similarly, cos x by sin x cot x, 1 by sin is cosecant x. So you can write the two terms as secant x into tan x, cosecant x into cot x, whose integration is a direct form. First integration is giving you secant x, second integration is giving you minus cosecant x. So integrating constant c. So divide the denominator and cancel the powers, split the remaining one to get a comfortable form for which we have integration formula and substitute it. Coming to next one. 1 plus cos 2x by 1 minus cos 2x integration with respect to x. So multiple form of cos. Two forms are used here. 1 plus cos 2x is 2 cos square x. 1 minus cos 2x is 2 sin square x, which gives you integral cot square x. But you don't have the formula for cot square. You have to change it into cosecant square, which is having a formula. So using fundamental rule, cot square can be written as cosecant square x minus 1. Now integration of cosecant square x equal to minus cot x, integral of a constant equal to x, integration constant c. So you are getting c minus x minus cot x. Next one, integral 1 by 1 plus sin x. You don't have anything in the numerator. You have only denominator and you have to integrate. But no special formulas for fractions given. That's why we have to take the help of algebra rationalization property. Here is a plus term, we are multiplying with minus term, so that we can have 1 minus sin x in the numerator, 1 minus sin square x in the denominator, which leads to a single term which is cos square x. So 1 minus sin square x is leading you to cos square x single term in denominator, which gives you immediate chance to split the numerator. So 1 by cos square x minus sin x by cos x into 1 by cos x. 1 by cos square is secant square. This is secant into tan. So integration of each one is a direct formula. Integral secant square is giving you tan x. Integral secant x into tan x equal to secant x. So that you are taking help of rationalization to get a function in numerator and to avoid these two terms of denominator as a single term. The two are converted into single term, so which is easy to split the numerator. And again, you are getting comfortable formulas. So each and every problem is a different one. Depending on the numerator and denominator, or depending on the function, you have to decide how to simplify it and how to come out of the fraction form, like simple form. So fraction to simplest form conversion is the very important point. So we follow everywhere some different procedures to get simple forms, and then directly writing the integration formulas. Coming to next one, 1 by sin square x into cos square x. 1 is giving you sin square x plus cos square x. Again, take the numerator and split each term with sin square x into cos square x. Division is giving you sin square by sin square cancellation, 1 by cos square x as first term, cos square by cos square cancellation giving 1 by sin square x as second term. 1 by cos square x is secant square x, 1 by sine square x is cosecant square x, whose formulas are directly integral secant square x is giving tan x, integral cosecant square x is giving minus cot x, integrating constant c. So observe all the problems. What are the tricks you are playing to disrupt the fraction and get a single term for integration? Everywhere we are using some different style depending on the function given to you. Okay? Right. Next, root terms. Integral sin x plus cos x by root of 1 plus sin 2x dx. Same trick we are following. 1 plus sin 2x is 1 is sin square x plus cos square x. Sin 2x is 2 sin x cos x, which is a square b square 2ab, so a plus b whole square, and root is a removing square. You are getting a plus b, that is sin x plus cos x. Both numerator and denominator is same, so integral 1 dx, which gives you x plus c. Coming to some different functions, exponential functions. Integral e power a log x plus e power x log a. Here we are applying m log a equal to log a power m. With that concept, this can be written as log of x power a, and this is log of a power x, whose integration is taken. E power log means both will cancel and you will get x power a plus a power x. It's not modulus, sorry, it's an integration symbol. Now here it is, x power a is x power n form, so a plus 1 by a plus 1. Whereas a power x is different one, whose integration is a power x by log a plus c. So take this a to the power of x and x to the power of a, which gives you direct contact of exponential function with the logarithm. So both will get cancelled and only argument will come as a function. Concept of logarithms, which you have completed in first semester. Coming here, e power 2 into log of cot x. So the 2 will come as the power of cot x, e power log of cot square x. Finally, it gives you integral cot square x dx. Integral cot square, you don't have any formula directly, so transfer it as cosecant square x minus 1 using fundamental rule. Then integral cosecant square x is giving you minus cot x. Integral 1 is giving you x plus c. Similar way, e power minus log of cosecant x means this minus 1 comes as a power which shows 1 by cosecant, that is sine. So finally we are getting integral sin x dx, which is equal to minus cos x plus c. So in this way, exponential function is given any power extended terms. Use your logarithm property as well as considering the function only and taking the integration. Okay, so some examples of exponential functions. Now, antiderivatives, we are going to use the antiderivatives word here. The velocity at any time t is given by v equal to 2t plus 1. Find the displacement s at a time t equal to 3, given that s equal to 0 when t equal to 0. So a displacement of a particle is given in small s, that clearly must be expressed in t. But to get the displacement, we have given velocity. So velocity is obtained by differentiation of displacement. We know it. Therefore, given that v equal to ds by dt equal to 2t plus 1, which can be written as ds equal to 2t plus 1 into dt. You require s, but you are having in hand derivative of s. Because the integration is a reverse process of derivatives, you can remove the d by integrating. So capital S equal to integral ds, which is equal to integral 2t plus 1 into dt. 2 into t power 1, so 1 plus 1 by 1 plus 1. Constant with respect to which variable you are taking the integration, that will come. So till now we have integrated with respect to x, that's why we are writing everywhere x. Here we are integrating with respect to t, so we have to write t. Observe the derivative with respect to which you are doing. So here it is dt, so you are getting instead of x, it is t plus integrating constant same. Finally, t square plus t plus c is your displacement s. Okay, we got it. What they are asking for us, displacement s at time 3 equal to 0. When t equal to 0, s equal to 0 given, and we have to find displacement at t equal to 3. So when s equal to 0, t equal to 0, what will happen to this displacement expression? Capital C is also 0. Now we got the equation correctly. S equal to t square plus t, which is representing the displacement. Finally, they are asking us to find displacement s at time t equal to 3. So put t equal to 3 in the equation of s, so that you will get 3 square plus 3, that is 12 units. So when t equal to 3, the displacement is equal to 12 units. Now you are able to understand what is the reverse process of differentiation clearly here. So integration is reverse process of differentiation. I think now you are able to do these integration basic model of problems with the help of direct formulas. In the next session, we are going to do methods of integration. So we conclude this session here itself.